My name is Denis Yaremov, programming for rough 20 years or so. And I've been in the industry for around 15 years already. I've been working on a wide variety of different projects, web projects, different financial projects, banking, insurance, loans, real-time trading. I've been working with data processing, artificial intelligence, and throughout my career, I've seen a lot of not very nice code. I've seen a lot of shitty code, actually. And the fact is that I'm not the only one who was seeing this code, and throughout this history, there was a lot of projects which code was very, very bad, I would say. And this picture, it shows a brief history of software architecture. It's not my picture, I haven't drew it, I just found it on the internet. And it shows how our architecture has been evolving throughout the few decades. In 1990s, we had like no architecture at all. We were using copy and paste extensively. And only in the beginning of 2000s, we were starting to sort things out. We were taking advantage of layered monolith, which is, by the way, lasagna-oriented architecture. We were taking advantage of SAW, service-oriented architecture. And now we have this ravioli-oriented architecture, which is microservices. So call it as you like, but it looks like, in the end, we are having this. The same kind of thing that we face every time and every. It's a spaghetti, just differently shaped, differently named, but this is still a spaghetti. So we're like walking in circles, and let me explain why. So as soon as we start our new project, everything seems really fun and entertaining. But we use top-notch technical technologies that there is. And our work is pretty much about research and development. And it's really nice to work in this kind of environment. But if we have a large team, year passes, and we're finding ourselves in a bit different position. We're starting to think that, whoa, how did we get here? Why our code why is it so complex? It shouldn't be, because everything seemed nice just yesterday, but now we have these problems that we can't do anything without breaking something. 5 years passes, and it becomes even more funner. So you go to your project manager, you start telling him, hey man, you see our project, it's so complex, we can't change anything without breaking half of solution. And you tell him that we need to rewrite everything from scratch. Well, while your project manager says, oh, yeah, but you see, it's not the way to go, because we're an enterprise, baby, and we like enterprise projects have to be complex. But this thing about complexity, about calling things enterprise or non-enterprise, it has some basis around it. What does it mean that the project is enterprise or not enterprise? Why do enterprise projects have to be complex? And this is the way to hide our misunderstanding of core reasons why applications become complex behind this term, word enterprise. And this is not the only word that we're typically using, because there is such thing as business logic. This is the bandit that actually makes our applications complex. Seriously, what other things other than serving requests our applications do? So every part of our application is an endpoint which serves some data or provides some HTML covered with, the data covered with HTML. In this case, business logic itself is also another buzzword that we are used to call our code. So data requests, which are actually the request response cycles, they're doing nothing except providing you with data or serving you with save data kind of queries. So you do nothing except, I mean, when we are developing our endpoints that do something really important, we're doing nothing except asking a database in some very specific way about, give me this data, give me that data, or set this data, change it or delete it, change that data. And the amount of work that we do is enormous. But why? Why do we implementing these get data, set data queries each time in their own unique way? Why does this happen? Why does these things make our applications a one pile of spaghetti on a plate? And to answer that question, let's just consider an example. Let's imagine that we would need to show a list of employees on our page. What do we do in order to show this data? So user clicks on some link and the application should show a list of employees. So first thing we need to accomplish is that we need to create a data query, because the data is located in database and we need to get it from the database, so obviously we need to create this query. Second thing is the supporting code. We need to trigger that query to get the data on the UI. And this part is very, on different projects, it may consist from different amount of steps. If you're working on large application, you most obviously you were working with different layers of your application. And you need to pass this data through all of your layers up to the top level where you can query it using, you need to pass it through all of your backend layers where you can query it using AJAX request. But this doesn't stop us from doing any additional work. So we also, after receiving this data, we need to transform it for the purpose of some, for the purpose of consumption by some UI component, or we need to combine this data with data that comes from another request. So we're doing this amount of work. So we're preparing data for the UI, and then we're making the binding. We're showing this data on the UI, and this seems like pretty huge amount of steps that we need to accomplish to serve just really simple purpose, show some information on the web page, right, or a mobile application. So that's not all, because we need also, this was just getting the data from the database. We need to double those steps that we were previously talking about in order to change the employee. We need to triple those steps when we're talking about deleting an employee. When we're talking about bulk change operations, we need to quadruple these things. And this poses really huge amount of code, which does nothing except taking things from one place, putting it to another place, transforming these things, and this is like all of the logic that we do. I mean, it doesn't seem all that unique. This work doesn't seem all that unique. And in the end, we're like in this state when developing our applications. Because these steps that we've mentioned, they are still not everything that we need to work on. Because every step that we've mentioned about previously, it can be subject of error, and we need to think about error handling. It effectively, for a good case, when you're writing a good application, you should think about error handling on every separate step. Performance degradation. How many times we were writing an application that seemed to be working in test environment, but as soon as we push it to production, voila, nothing works. We need to spend efforts on making our application just work. And then there's bugs. So when we have written such huge amount of code, this code is always subject to bugs. And we need to spend time, spend effort, spend money on making things work, which is actually was initial purpose, just get data from database and show it on UI. Oh, sorry. So the amount of code that we produce, it's enormous for this really simple things that we do. And that's why actually our applications suck, because there is no other way that we're typically organizing our architecture. We're typically organizing our architecture into request, response, cycle, and making our application consisting of these request response cycles like spaghettis on a plate. And having a control of this architecture is pretty non-straightforward. So because we make request responses, these things makes our application suck. So this is the bandit that makes everything not well. How can we change this situation, and what is the core reason why we make request responses? And this is the thing that bounds us into request response. The answer lies here. So a database is the root cause of request response cycle because it has non-parametric nature. Imagine that you have written a query to get the list of employees. You cannot use the same query to get the list of Pokemons, right? And so in order to get this list of Pokemons, you need to implement all this pile of code that we were talking about previously. So we cannot make our applications better if we will be querying data, making ad hoc queries at the place where we need data. We need a better pattern for that. One moment. And so until we keep on doing this, we will not be able to create an offline first application, because ad hoc queries stop working when connection breaks, right? So moreover, the application itself, it becomes very like bulky, slow, insecure, because we're making errors, security errors when we're writing our code. And so this architecture, it existed for nearly 50 years. And request response was a core part of this architecture. And traditional approach, it blocks offline first. So let's try to discuss some non-traditional approach and try to build our offline first application. Let's do it just in our imagination at this point in time, and try to figure out how can we stop making these errors, how can we think of something new, how can we create an offline first application. And in order to start doing this, let's ask ourselves a question. How are we working with data? How are we storing it? How are we acquiring it? How are we using it? So so when the client accesses our application, we cannot, in order to provide an offline first capabilities, we have to think of the way that we would allow a person to access data when there is no connection. So how do we do this? Obviously, we need to send a little more data to the client, and actually we need to send all of the data that is related to a client, and allow him to work just with this kind of data. So this is the first thing that we need to do. As soon as some updates happen to the data, we could send these updates, we can push these updates from server to client side, and he can therefore change his initial state, old state, obsolete one, to a newer one. And so when application goes down, or a server goes down, or a network connection occurs, we have all of the necessary things to work with we have all the necessary data to work with our application. So imagine that we have sent from server to client side for around 10, 20, or 50 megabytes. What do we want to do with this thing? How can we limit the bandwidth and not sending this data once again to this server? So any thoughts? How can we send? What can we do with data when it has been sent to a server? To a client side, and it's a pretty huge amount of data. What can we do with this data on the client side? Sorry? Pack. One way of doing that, but obviously when our application restarts, we need to, right? What other technologies do we have to save this data? Because local storage only 5 megabytes allows us to start. Sorry? Storage API, yeah, so IndexedDB, WebSQL, MySQL, if we're talking about other platforms, non-web platforms, let's say iOS or something like that. So we need to save this data and not acquire it every time. And we need to get just the difference between every time the connection goes online. We just need to get a difference from the moment that person went offline and the moment that is right now. And the server has to supply us this difference. So having this kind of scheme allows us to organize an application where client never asks for data. All of the necessary data is already on the client. Another thing is to identify the data that is related to a user. How many of you have been working with probably offline capable applications and we're trying to maybe some existing technologies that there is, maybe Meteor.js? Please kind of raise your arms if you have been working with this. So we have a few people, thanks. Okay, and Meteor uses special approach to this kind of problem. It allows us to subscribe for queries. And as we have talked already, queries are not that, I mean, they have some problems. First of all, they pose huge amount of supporting code. And independent what kind of query it is, where it's done, we need to support it. We need to kind of analyze, we need to make sure it's working. And we need to, for every specific query, we need to do this error handling, etc. We need to analyze whether it's still capable to work or not. So another problem is the fact that queries and subscription to queries are not accountable. We cannot be sure that our query will produce normal amount of data. We cannot be sure that at one moment in time, our query will produce 100 megabytes, which we will not be able to download from server to client. And we cannot run our query through all of the possible parameters to be sure that it does work well. And so let's talk about permissions. We have this permission slide. So what are the permissions? What are we using permissions for typically? Why are we using them? So any thoughts? Separate users' data, so that person doesn't get some wrong data that he is not allowed to, right? Okay. Separate user access. So this is the security mechanism. On the other hand, imagine this really interesting use case. So imagine Jira. You're entering your typical day-to-day work tool, and you don't see every part of information that is stored in Jira. You see just data that you have access to. And it becomes the fact that permissions are one mechanism to not only provide security, but on the other hand, it allows us to separate and limit the amount of data the user has. The key difference between subscription to permission and subscription to query is the following. If we are creating each piece of data in our database with a link to permission, we can easily account how much data there is linked with this specific permission. We're putting these permissions into roles, users' roles, and assign these roles to a user. And eventually, we can easily account how much data the user will end up having. So this is one way of distinguishing data. It allows us not only to make our system accountable, but also allows us to make it safe too, because the user, which is subscribed to permissions and obtains his data automatically, he will not ever get the data he is not intended to get. So another thing is the way how we deal with data. So how we typically dealing with data. We're making our data is graph. So when we requesting our data through AJAX, we're getting objects which are actually represent some linked data between themselves. So we have entities which are linked, and in this way, this is very convenient to work with data. But this is the way we cannot send data to the database. We cannot save data using native links. We unscaffold our data, replace links with IDs, and this is the way we are able to save it. So where is our typical place where we scaffold data? It's typically done on a database. We're doing joins. But is it the best place for joining data? The answer is no, because getting very complex data structure from a database may take a very huge amount of time. And since if we're talking about joining data on the client side, we are in position to where we're making search over where we have a key, yeah, we have a reference to some entity. The complexity of this operation is constant, big O notation of 1, which is way faster than this same action done on the database, because we use special algorithms to find the data before we want to link it. And if we were to do these operations on the client side, it would be faster and it would be independent of data structure. The last thing, it's not the last thing, is, it's not the last thing. So another thing is the fact how we working with conflicts. So when we're talking about offline first applications, we can constantly find ourselves in a position of when some people change the data and other people who are offline also change this data, and we're getting a conflict. So how to manage conflicts? How do we dealing with conflicts in real life? So imagine a person, some person has created some piece of data at moment of time 10, then edited it, and then edited it at the moment of time 30. But one of the guys who was also working with this data has gone offline within this piece of timeline. And he made changes. Which version is the most correct one? Whose data is right? Whose data should be kept? Whose data should be deleted? There is no one there is no one answer to this question. And obviously, we are in position to save all of the versions. And when we are saving all of the versions, we can easily show these versions to a user and be able to provide a mechanism for the user to take part of the conflict and merge it manually. If you have two versions, if user sees two versions before his eyes, he can easily take parts of this data and put it from one version to another and delete one of the versions. And this way, he will be able to manually manage this problem. And no need for a system to take the ownership of this process. So how to work with this kind of data if we're saving all of the versions? How can we work with this kind of data? Well, if every piece of data is equipped with timestamp, it becomes really simple. because we only need a get latest query, which would allow us to get the latest state of the system. And this is if a person went offline on this part when he had version 2 in his repository, then when he comes back at moment of time 40, he will provide his latest timestamp, which is 20, to the server, and server knows that now he has the latest data in the database is at the moment 40, so we can easily find through really simple queries, select everything from a database where timestamp is more than 20. So these will be the versions that are new to the user, and this is really simple to compute, so we don't need very complex code to get this kind of data. And in reality, this query it's a bit more complex because we need to cut off intermediate changes. If the person has went offline a year ago, he doesn't want to see every change that happened through this year. So we need to think about how to cut off intermediate changes and leave only latest ones. And it's the same. This query will have the same nature. It will be as simple as the previous one, maybe a bit more complex. But the idea is that the nature of this get latest query is very simple. And now it would be great if this technology has existed, and in reality it does exist, but currently in closed beta, and we're working on the fact to make it available for everyone. So Reflex it's not a technology, it's a methodology that allows you to create offline first applications which are very responsive, very interactive, which are very fast and secure. So you can cover your applications with Reflex. You cannot cover every part of your application with Reflex, but you can use it to cover like 80% of your application, 90% of your application. You cannot cover big data tables with Reflex because this would make your clients to become more overwhelmed with data. So you're covering the entities that you have in your system. And in the result, let's probably see how it looks in reality. So I have this thing to show for you. One moment. Oh. So I have a demonstration how this system works and what it looks like to work with this kind of approach. One moment. Okay. Let's use this system is implemented. This system is implemented with C# with .NET C# in the backend. We are working on providing Node.js version right now of server. So the ideal thing is that when we will have ability to install this approach like MVC into different kinds of projects, different kinds of languages, which it absolutely perfectly works, is able to work with. It's able to work with different databases. And so let's start. I won't go through code in great detail, but I'll just show you the concept, how these things work. And this is just one of the test applications that we have. So this looks like a simple, I'd say it's absolutely simple, absolutely typical application. One moment. Oh, one moment. So this looks like a simple, typical application that we are actually do. And what are the things? The thing that we're doing right now, we're creating an air flight, the airport flight. So in order to do this, we need to pick an an airplane, and we have this search right in here. It works all from the local side, so we're not triggering, in any case, server. So all of the information we need, it's already located on the client side. We have picked an airport, then we're proceeding, we're creating the information about the flight, specifying some IDs, the amount of passengers, the path that the airplane will be following. We're picking the source airport, departure airport, arrival airport, so let's say Ukraine. So we have, this is the full text search. As you can see, we have all of the, we're searching for airports that has Ukraine within themselves. So let's pick one of the airports. Let's use Sumy. Or let's use, for example, as example, Vinnytsia. Oh, we have Vinnytsia. Okay, so we are ready to create our flight. We press submit, and here it is. So imagine that we have several browsers. Let's use, for example, let's use another browser to see how interactive is the application. One moment. Oh, let's use countries. So the same thing, we are using, this is the full text search query, which is implemented on the client side. We're able to search for everything. We're using, let's search for Ukraine. And as we see, Ukraine has some strange X after it. Let's just fix that. But before we do that, let's just inspect our console and see this. We have Reflex repository that contains, by the way, all of the data structures that there is in related to this current user, which is the following. Here is the list of aircrafts, pretty huge. Oh, it's not that huge, but it's a test database. So we have all of the possible aircraft types. We have around 20 megabytes of data here, and as you can see, if we will reload our page, it takes seconds to load. So let's find our Ukraine. Reflex, repo, query, references. And we can use any kind of wildcard to find Ukraine. We're searching in country, in table countries, and let's put it to U, a variable. Okay. Oh. So here is our Ukraine. Here is the version that represents Ukraine, which is Ukraine X. Let's change it, let's say, to just Ukraine. Accept, save. Okay. So let's see how our Ukraine is doing. Versions. And voila, we have Ukraine here. As you can see, we had the ID of the version is changed. So we have one version of Ukraine, now we have another one. So basically, Reflex takes its own, he takes the responsibility to work with data for you. He will send you all of the necessary stuff that you would ever need. He will be able to answer the question how much stuff there is to send. And basically, you will stop worrying about asking for data. You will just take it, bind it to UI using any innovative technology such as Angular, Flex, Flux Redux, Angular 2, any technology. You just take the data, and it's automatically managed by Reflex. He will take the necessary parts. So how much time do I have? 6 minutes. Let's probably, the last thing, the offline, right? So I need to prove you that this application works offline. So I'm stopping my server. I'm closing. So console says that we have connection, that our connection has broken and tries to reconnect. So if we were to edit our Ukraine back into kind of Ukraine X and press save, in this case, we would get two versions of Ukraine. This is not required way of implementation, but it allows us to actually act in any way. We can just show the latest version. We can show just the first version. So in any case, this browser doesn't see the change because server is down. Let's bring our server again up. It starts new tab. So, whoa, oh, one moment, it's starting. Oh, we have Ukraine X. So the idea is that the core concept of this technology is multi-dimensional data. The data that can be that can have several versions at any point in time. Dealing with this data is the innovation that Reflex introduces. And it shows an absolutely new approach to the way we work with our applications, the way we organize them, the way we are working with things. So this is it for my presentation. If you have any questions, I'll be glad to answer those.
Denis, thanks a lot for such interesting speech. Everybody definitely like it, and we have a little time for questions. And raise a hand. And
без проблем.
Что вы будете делать, когда с бэкэнда приходит большой объем данных? То есть, скажем так, вы сейчас являетесь админом, да? У вас полный доступ ко всей базе. Эта база весит несколько сотен мегабайт или гигабайт. Как с этим делать?
Я тогда просто переведу на английский и попробую ответить на английском, если вы не против. So we cannot deal with big data tables using Reflex. The idea is that when we are working with standard applications, 80% of tables contain a small amount of data relative to one user. Take Jira. You don't have 1 gigabyte of data for this purpose. You can cover all of the necessary data. You can fit it into around several megabytes, I would say, several tens of megabytes. It's not a problem to send 100 megabytes to the client at our current stage. If you will open, for example, Apple site, you will get 50 megabytes of graphics. And if you will scroll down your Facebook, you will see through your task manager that the tab that opened Facebook now weighs 1 gigabyte. And this is the data that we're actually getting, and applications are okay to work with large amount of data. The idea is that you cannot, you are open to select which data to cover with Reflex. If you have big amount of data, you are open to make a request. But it will eventually cut your expenses, request response expenses at making this kind of requests, et cetera, down to 10% or something like that.
Okay, thank you.
Okay, we have time for one more question. And Cons?
Have you compared your technology to other similar technology? Well, okay, they're not similar, but can you compare them to something like Swarm.js?
Yeah.
Or Hoodie,
Thank you. So yeah, Swarm.js is a very scientific project. So it implements CRDT approach, way to merge your conflicting versions, way to. It's different. I cannot say this technology is better or this technology is better. These are tools, and every tool has a task which it is intended for, and so it's different. The core difference between these technologies is the way we treat, the way we feel about data. So using Swarm.js, you would want to kind of press your data into one version, even if there is conflict. You will have to work out your conflicts at different points in time. But using this technology, you're open to delegate this thing to a user, which is really simple idea. So there are just few projects implemented with this technology, and I cannot say at this point in time that this is the holy grail, right? But this is new. This is really interesting. This thing allows you to see development from absolutely different perspective. And I strongly encourage you to see our contacts. And one moment. And save it we are making announcements on Twitter, we're making announcements on Facebook, and I think till the end of the year we will have open beta, which you will be able to use for your own good, and try and give feedback how good is it, how bad is it. So that's actually it. Thank you, everyone.
Denis, thanks for your speech one more time.